Let's take a look at some sample problems from section 8-3 on testing a claim about a proportion. We'll begin on page 408 with number 5, and we're asked to do 5 things for each one of the problems. First of all, is the test two-tailed, left-tailed, or right-tailed? What is the test statistic? What is the p-value? What is the null hypothesis, and what do you conclude about it? And then what is the final conclusion? So as we look at number 5, what we see is we have TI-8384 plus printout over on the left, and it says the drug Symbicort is used to treat asthma. In a clinical trial of Symbicort, 18 of the 277 treated subjects experienced headaches, and they tell us where that data came from. The accompanying TI-8384 plus calculator display shows results from a test of the claim that less than 10% of treated subjects experienced headaches. Okay, so our first question is the test two-tailed, left-tailed, or right-tailed? We look at proportion is less than 0.1, so it would be a left-tailed test. B, what is the test statistic? That's the one labeled P hat. I'm sorry, that's the one labeled Z. And our Z is negative 1.94. Okay, and C, what is the p-value? That's the one without the hat, and that's 0.02. Alright, what is the null hypothesis, and what do you conclude about it? Okay, the null hypothesis would be that P is equal to the 0.1. And now comparing our p-value, we're told alpha in the directions is 0.05. Because the p-value is less than alpha, we're going to reject the null hypothesis. And they have a little saying here that I thought might help you with p-values. If the p is low, the null must go. So if the p is low, the null must go. So we see this p-value is less than the alpha. So if the p is low, the null must go. Alright, so now we're ready to write our conclusion. And it looks like from a test of the claim that less than 10%. So we've rejected the null hypothesis. That means the data support the claim. The less than part was our claim that less than 10% experienced headaches. I'm running out of space, so okay, ran off the edge there. Okay, in number 7, we have a stat disk printout. Since the calculator and stat disk are the two technologies we use, that's why I chose numbers 1 and numbers 5 and 7. 7 says brand recognition. A PriceGrabber.com survey of 1,631 randomly selected adults showed that. I accidentally turned my. There we go. Showed that 555 of them have heard of Sony Reader. The following stat display results from a test of the claim that 35% of adults have heard of Sony Reader. Okay, so in this case, we have it's equal to would be our null hypothesis. I'm going to go down here. So P is equal to 35%, so 0.35. And so not equal to would be our alternative, so that would be a two-tailed test. Part B, we want our test statistic, and it identifies it as negative 0.28228. C, what is the p-value? The p-value is 0.4106. And again, our alpha is 0.05, so we see that the p-value is greater than alpha, so we fail to reject. The null hypothesis. That's actually part of D. Let me move E up here. Alright, so for E, we want to say the data support the claim that the proportion of people who have heard of Sony Reader is 0.35. Okay, now in the next one, we'll be doing the entire hypothesis test. And I'm going to do two of these the longer way, and then I'll do two using StatDisk. Okay, M&Ms. Data set 20 in Appendix B lists data from 100 M&Ms. And so N is 100. P hat is 8% of them are brown. Okay, we want alpha to be 0.05. To test the claim of the Mars Candy Company that the percentage of brown M&Ms is equal to 13%. Okay. That's our claim. So this would be not equal to. So it's similar to the last one we just looked at. So we want to find our test statistic. So Z equals our P hat minus our P times the square root of 100 all over square root of P hat. Is it P hat or I always get that confused. P hat or P? It might be P. Okay. It's PQ. Okay. So let me get the right one in here. 0.13 times 0.87. So if Q would be, since P is 0.13, that would be 0.87. Okay. So let's see what we get. Oops, I gotta grab my calculator. Okay, we're going to have negative 0.05 times 10 over square root. I'm just going to leave that for now. Alright, so negative 0.05 times 10 equals, and then divided by the square root of 0.13 times 0.87. And I'm getting negative 1.49 is my test statistic. Okay, so 0.025 goes in each tail, and we look up the negative table. 0.025 is negative 1.96. Those are our critical values. So negative 1.49, here's our critical region, and here's our critical region. Does not fall in the critical region, so we fail to reject. So that means for us, we're failing to reject. The original claim includes equality, and we fail to reject. There is not sufficient evidence to warrant rejection of the claim. Let me go over here. Rejection of the claim that 13% of M&Ms are brown. So as you can see, that took the whole table. Now if we did the p-value method, we would look up the p-value we could look up the p-value by looking up negative 1.96 on our table, and then doubling the area. Alright, negative 1.96 would be 0.0250. Let's see, not 1.96. We want negative 1.49. I kept thinking that's not right. 1.49 is 0.0681. So the p-value is coming from the test statistic. Alright, and because we have two tails, we have to double it. So 0.0681 times 2. That's 0.1362, which is greater than our significance level, so it would also lead us to conclude that we've failed to reject the null hypothesis. Okay, let's do number 12. I think we'll do number 12 both ways, and that way 14 we'll go ahead and do by the calculator. In a 3M